This is the type of problem that really separates the people who are going to get 3s and below from the people who are going to get the 4s and the 5s on an AP Calc test. What we have going on here is a little bit hard to decipher at first, but once you've seen it once, you know to expect it, and you should be better prepared the next time you run into something like this on an AP Calc test. First off, we're being told that this function is continuous on a given interval here. And then we're being told some values of the original function. We're being told at those endpoints of that interval that both of those endpoints are equaling 0. Then they come along and they start telling us something which is strange. Then they're like, okay, well, there is no value of c inside that interval such that our derivative is equal to 0. So you say to yourself, okay, well, how am I supposed to relate y equals information, original function information, to derivative information? And that's really where you got to look to the mean value theorem. Again, this is one of those theorems that you just have to know like the back of your hand going in to take this test. The mean value theorem says if I have a continuous function on a closed interval from a to b and it's differentiable, there is a derivative value on the open interval a to b everywhere, then I get to draw this final conclusion. My conclusion is the f of b, the y value from my endpoints, basically the slope connecting my two endpoints, my average rate of change between my endpoints, has to equal my instantaneous rate of change at some point in between there, that there has to be some c value in between those two endpoints such that the derivative value equals the average rate of change between those 2 points. So if I look at what I've got here, I have my closed interval and I've got the y values going with it. What I have is what's going on the left-hand side of this. So it's saying f of negative 3 minus f of 3 all over negative 3 minus 3. This would end up giving us both of those are equal to 0. So this would be 0 minus 0 over negative 3 minus negative 3. And so out of there we get that this is 0. So we're getting that this left-hand side here, this average rate of change, is equal to 0 between the two endpoints of our interval. However, what they're telling us is there is no c value. We're not going to be able to find a c value such that the derivative is equal to that the derivative is equal to 0, right? So it's saying something happened that isn't going to allow our final conclusion on the mean value theorem to go forth. So what you do now is you got to come back and look at the if portion of your mean value theorem. So you'd come back and say, okay, if it's continuous on a closed interval from a to b, well, they told us the function is continuous on a closed interval from a to b, so that checks out. Then we go and say the second part, and it's differentiable on the open interval from a to b. Well, as you look at all that info that they gave you in the starting sentences, nothing up there guarantees that this thing is differentiable all the way from our endpoints from negative 3 to 3. So what that tells us is we can now draw the conclusion that since this mean value theorem didn't hold, that means that one of those two pieces at the front didn't work. And what we now know is that it was continuous, but we know it's not differentiable on that whole interval. So they call it a to b. Ours would be negative 3 to 3. So we know in this interval here, at some position, at some x value, it's not differentiable, which meant this part of the mean value theorem failed, which means we weren't able to draw the final conclusion. So as we come back up here, we can see that option C says that for some value in between negative 3 and 3, the derivative does not exist. The derivative is not differentiable. And so that would be our final answer here. So again, this is a higher level question that's definitely going to be something you want to be aware of. It's involving the mean value theorem. Whenever I've got an original function, an f of x, and I'm trying to relate it to my derivative here, the mean value theorem is very often what you want to use. And remember that if a theorem doesn't work, if you cannot draw that final conclusion at the end, that means one part of your if statement didn't hold true. Well, on this one, it was continuous, but that means that the other piece that was required, that it's differentiable on that same interval, didn't hold true. And so once you know that, now you can go back and look at your options and see what the right answer would be. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.